In this video, we'll be talking about how to find the surface area and volume of a right rectangular prism. A rectangular prism is a solid with two rectangular bases that are parallel and congruent. Remember, this definition of two bases that are parallel and congruent applies to all prisms. A prism is considered a right prism if the lateral faces, in other words, these faces that are not the bases, are perpendicular to the bases. The height of a prism is the perpendicular distance between the bases. In the case of a right prism, what some people might refer to as a box, there are actually three different pairs of faces that could be used as a pair of bases because they are still parallel and congruent. For example, in this particular box, we could use the left face and the right face, those faces on the sides of the box. We could use the front and the back faces. Those are also parallel and congruent. Or we could use what appear to be on the top and the bottom of this right prism. It does not matter which pair of faces you choose, so long as they are parallel and congruent. The other faces, of course, will still all be rectangles. Most oftentimes, people will choose the top and the bottom, but it does not matter which pair you choose. So in the case of what I'm going to be looking at here, I'm going to choose the, I don't like that color. I'm going to use the top and the bottom as the bases in this case. So I'm going to see this top surface as one base and the bottom surface as another, which means these remaining four rectangles are my lateral faces. Lateral just means sides. And we can see in this case then if this bottom face is, let's assume it's horizontal, then this segment that connects these two bases, that edge, is going to be perpendicular to that base. Likewise over here, although it doesn't look like it, this edge would also be perpendicular to the bottom face as well. So in that case, if I'm using the top and the bottom as the bases, then this distance between the bases becomes h. And in a little bit when we do our examples, we'll be looking at the same prism, but we'll accomplish it in two different ways. We'll look at how we can find the volume and find the surface area, assuming one pair of bases, and then we'll do it again, assuming another pair of faces are these bases, and see how that changes the work, but doesn't change the end result. So as always, our surface area of a prism is 2 times the area of the base plus the perimeter of the base times the height. And the volume of the prism is the area of the base times the height. So with that in mind, we have here a rectangular prism. And as I said, I've got the same prism drawn twice with the same dimensions. A height of 3 feet, a width of 6 feet, and a length of 10 feet by general assumption. All right, so as I start off, I'm going to, in this case, use, as I did up in the example, I'm going to use this as my pair of bases. So here I'm going to use what appear to be on the top and bottom of this rectangular prism, which means my base is a rectangle 6 feet by 10 feet. So the area of that base, the area of that rectangle, is going to be 60 feet squared. And the perimeter of that rectangle, 10 here, 10 there, that's going to make 20, 6 and 6 on those apparent sides, make a distance of 12, so we're up to 32 feet total. And then we're ready for the surface area and volume formulas. Generally speaking, these problems tend to be more just repetition than anything else. They're not meant to be difficult by any means. Substitute in the area of the base 60 and the perimeter of the base 32. Now we've said all along that the height of a prism is the distance between the bases. So since I chose the top and the bottom as the bases in this case, the distance between them would be this 3. That's going to become my h value. So that substitutes here in the surface area formula. Now you're ready for your calculator. 2 times 60 plus 32 times 3 gives us an actual surface area of 216 feet squared. Now let's look at the volume. Volume is the area of the base times the height. So the volume in this case, the area of the base is 60 times the height of the solid, 3. 60 times 3, 180 feet cubed. So that's the process that we'd employ if we were using what appear to be the top and the bottom of this prism as the bases. Now let's accomplish the same goal, but let's choose a separate pair or a different pair of faces for the bases. They still have to be parallel and congruent. So in this case, I'm going to choose what I would, or some people might refer to as the left side and the right side. So now I'm going to use this pair of rectangles for my bases. Now keep in mind that when you change which bases you choose, you are changing the distance between them, which means you are changing the height of the solid. So in this case, the distance between the bases that I've chosen is 10 feet. So now this 10 represents my height. And the base is now a rectangle that measures 3 by 6 feet, which is what we see here in this shaded portion. So changing the base not only changes the height, it's going to change your capital B and capital P values as well. So the area of my base in this case, 3 times 16, is 18 feet squared. And the perimeter of the base, considering 2 6s and 2 3s, 12, 18 feet. All right, now we're ready to find the surface area. So far our process is the same process that we're employing. It's just different numbers that we're putting into those positions based on the bases we've chosen. All right, capital B, 18 plus P is 18 times that height of 10. And that's going to give us 2 times 18 plus 18 times 10, 216 feet squared. Notice that's the same surface area that we got originally. Likewise, if we look at the volume, the area of the base times the height, our volume in this case becomes 18 times the height 10, or 180 feet cubed, which is also the same answer that we got up here. So on a rectangular prism, it does not matter which pair of faces you choose as long as they are parallel and congruent to one another, and you don't make any little goofball errors along the way. And that takes care of finding the surface area and volume then of a rectangular prism.